Hello, 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 ladies and gentlemen, and welcome back. Your friendly neighborhood root beer here, looking at question number 11, the very first question in Part B on our Grade 7 2018 Gauss paper. A cube has exactly 6 faces and 12 edges. This is just basic math facts. How many vertices does a cube have? Okay, and we even have a picture. It's not quite a cube, but that's for question 12. We'll get to that eventually. But, I mean, we could just sort of draw a cube to help answer this question. So a quick way to draw a cube is draw a square. Draw the same square just a little up and to the left, and connect the corresponding edges. Or connect this corresponding vertices by edges. And we could even count here. We do indeed have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. And we could count faces, this face back here, this face on top, the face back here, the face on the side here, the face on the bottom, and then of course the front. That would work fine as well. So we do really have 6 faces, but we're asked about the vertices, the corners. So 1, 2, 3, 4, 5, 6, 7, 8. So the answer is 8 vertices. So we can figure that out just by quickly drawing a picture. The answer is 8E. Now that's not the only way to do the question. If you've learned a bit more about geometry and specifically three-dimensional solids, you may have heard of something called Euler's formula, which is a nice relationship between the number of vertices, the number of edges, and the number of faces in a solid. Okay? And it works for things like cubes. I'm glad I always have these guys handy. Or things like a tetrahedron. That's a perfectly good solid as well. And what it says is, well, here, let's write down the formula, actually, if I'm going to talk about this. So, faces minus edges plus vertices is always equal to 2 if you're looking at a solid that doesn't have any holes in it. Okay? And most solids don't, but... so, for example, if we, that'll work for a cube. We'll do that in a moment, but let's look at the simpler case of a tetrahedron. Okay? Nice, solid. And it's got 1, 2, 3, 4 vertices. Okay? And it's got 1, 2, 3, 4 faces. Okay? So, for example, if I knew we were looking at something that had 4 faces and 4 vertices, we could solve for the number of edges. Okay? 8 is 2 plus E, and that'd tell me I need 6 edges, and you can even count with me to help verify the formula. We've got 1, 2, 3, 1, 2, 3 going around the top, and then on the bottom 1, 2, and then back here 3. So 3 and 3, 6. And that works for a cube as well. So if you knew this formula, a quick way to do the question was, well, not treat it like a tetrahedron, but they give us the number of faces is 6, the number of edges is 12, and they're asked about the number of vertices. Okay, so vertices will be 2, you'll subtract the 6, you'll add the 12, and you'll simplify to 8, and that's another way to get it. And that's a very useful formula to be aware of. Faces minus edges plus vertices is always equal to 2. Okay? And this is something you can even study in more advanced math, in university, and sort of third and fourth year, things like this come up. But they get generalized quite nicely to multiple dimensions, all very, very interesting. But this is just a grade 7 contest. We're not going to overload you with anything like that. But that's just 2 ways to do the question. Draw a picture, or if you know Euler's formula, and if you're looking for more information about this, I'll spell out the name in caps. Just because it never pronounced the way you think it should be. It's not Euler, like ruler. It's Euler. It's got a bit of an accent to it. But this is Euler's formula. Euler was a fantastic mathematician. This is just one of the things that he managed to notice. And that gives us an answer of E for question number 11 there. And we'll move right along in the next video to question number 12. I'll see you there.